Okay, next one. Y equals minus x squared, which is what I've done here. Is I've just stuck a minus in front of my original function. What will that one be?
Inverse it.
Inverse it. What do you mean by inverse it? You've got to be really careful with your language now.
Flip it.
Flip it. You're really careful with that language now. Come on, be more precise. Be more better communication for maths. You probably know exactly the right thing. You probably mean the right thing. Reflect in the x-axis. Yeah, that's right. Okay, that one is a reflection in the x-axis. Basically, anything that originally was positive is now negative. Now, originally it was all positive, so that is now going to be negative. And anything that was originally negative is now going to be positive. So if we're happy with that one, for the next one, can we just have a go then now at what will this one be? We have just done earlier on that without the minus sign gave us that one up there. So if I put a minus sign in front of it, what's that going to look like? Can we all draw it in the air? Yeah, oh, Greg, you didn't draw it in the air. Yeah, that's right. Okay. Yep. Okay. It will look like that. Okay. It'll be the one we had upside before, reflected in the x-axis. Right. Okay. So those are some, and we're going to keep on going. Next one, number 10. Y equals minus x all squared. So what I've done here is that is f of minus x. I've just replaced my x in my original function with a minus x. What is that?
Reflection in y?
That is a reflection in the y-axis, yes. So, before, whatever was happening at minus 3 now happens at plus 3. Whatever happened at plus 3 happens at minus 3. It is a reflection of the y-axis. What will our y equals x squared look like when it's reflected in the y-axis? Exactly the same, yeah, okay. So here there's actually no change for this curve. But that is a reflection in the y-axis, that minus sign there. This one here, I've replaced my original x with a 2x, so this is f of 2x. Anybody know what happens if I times every input by 2? Yes, you're right, okay. One way of thinking of it, what that is doing is pushing it in from both sides. So now everything is half, like the width, half the distance it is from the y-axis. So if our original curve was looking like that, our new curve will be half that height there. Instead of going all that way out, we will now just go half that way out. So this will look like that. It's been pushed in from both sides, so everything is now only half the distance it used to be from the y-axis. And you often get this sort of thing with trig graphs. So, first of all, y equals sine x looks like that. If I take that at 360. Y equals sine of 2x will look like, Billy's doing it with his head. Okay, you get twice as much curve for your money. Okay, it's been pushed in. So your original curve here, your original curve is now happening here. The original curve has gone there, it's being pushed in. So it's only taking up half the width, and because it's a periodic and repeats, you get another lot in there as well. Okay. Right, we're all keeping up. I'm sure you're all doing beautiful drawings on graph paper, accurately, totally accurate, much better than mine. Right, okay, next one. Here we go. Y equals 3, x plus 1, all squared minus 2. If you've got to do something like this in the exam, I would start off with, it's based around y equals x squared. What's the first thing that has happened to the x squared up here? Yes. Next thing, I would draw that one. Okay? Then, what happened next after that up here? It was times by 3. I would then sketch that one. And then finally, I would work my way through by sticking that minus 2 on the end. I would break it up into all the steps. So, do that. We'll see in a minute if we agree with each other. You could, of course, just type it into a graphics calculator. Yes. Okay. But they could, what they could do in a minute, they could put on a point on here in terms of letters rather than numbers and ask you where it ends up and things like that. So you've got to be able to work it out. So y equals x squared is that. X squared plus, sorry, x plus 1 all squared. What's happened at this stage here? What's happened at this stage here? Replacing the x with an x plus 1. Yeah, that is essentially left 1. So that is now there. What's happened over here? Sticking a 3 in front of it.
Stretch vertically with a scale factor of 3.
Yep, okay, so that's now much steeper. Okay, still there at minus 1. Then what happens down here to get to the last stage? Yeah, it's gone translated down 2. So that curve there, steep one, will be down here like that. What will that coordinate be down there? Yeah, we know it's negative 1, and then it's gone down 2. Negative 1, negative 2. That's right. Okay. So, if we think back here, 0.11, where has 0.11 ended up? Where is that point on here? Yeah, that's ended up here. It's gone 1 left. So there it was 0, 1. Where is that point on here?
Where?
Where is that point on this graph? 0, 3. Yeah, it's been stretched 3, so it's just 3 times as high. It's there. Where is that point on this graph?
0, 1.
Yeah. Okay. So you can sort of follow a point's journey through the transformations like that. And if they're given you, for example, the point AB, you can sort of work out, well, where's AB ended up? So Corey, well, you may not be able to answer with your graphics calculator. If you started out with the point AB on that graph, where would it be on this graph? If that was the point, talk about a general point on that, AB, where would it be on this graph here? Okay. Where would it be on this graph over here? Yep. Where would it be on this graph here? Yeah. So that's a lot of test of your understanding, which you couldn't necessarily do on your graphics calculator. Okay. Right, we'll pause that one there.